Hi guys, I'm going to do a quick video about ions and isotopes. That's what your newest lessons are about that have been placed in Google Classroom. They're all going to be Kami assignments, so make sure that you open with Kami. I will make sure and demonstrate that at the end of this video just to remind you guys all how to open a Kami assignment. But you have been working over the last few weeks on identifying the number of protons, electrons, and neutrons of the elements on the periodic table. And things that we should already know at this point in time is that the atomic number tells us how many protons and electrons an element has, and then its mass is equal to protons plus neutrons. So if you subtract the atomic number from the atomic mass, you now have neutrons. So the new thing that we're going to be learning about is an ion, and an ion is a charged particle. So the two parts of an atom that are charged is the proton and the electron. Protons are positive and electrons are negative. So typically when we're talking about an element from the periodic table, like beryllium, it has an atomic number of 4. It would have 4 protons and 4 electrons, which means that they would just cancel each other out because 4 positives and 4 negatives would leave you neutral. But what's going to happen when we start talking about combining elements and making compounds? They're going to either give, take, or share electrons, which is going to change their electron count. And through doing that, they're going to become charged particles. So one of the things that I want to go through and make sure that everybody has an understanding of prior to moving on is about valence electrons. Valence electrons is the number of electrons that are in the outermost orbital of a diagrammed atom. And there's some rules about that. And the rules are that every element that is in group 1, and your groups are numbered 1 through 18 across the top of the periodic table, but they run vertically. So this is all group 1. So every element that is in group 1 has 1 valence electron. So just as an example, hydrogen only has 1, but lithium has 3. So the rules of Bohr diagramming is the first level can hold 2 and the other levels can hold 8. So if lithium has 2 on its first level, then the next level is only going to have 1. Sodium has 11 electrons, so it's going to have 1 or 2 on the first level, 8 on the second level, and 1 on its outermost level. So that's just an example of me explaining to you. Group 2 is going to have 2 valence electrons. So beryllium has 4 electrons, so 2 on the first level and 2 on the second level. Magnesium has 12, so it has 2 on the first level, 8 on the second level, and 2 on its third level. And it would continue like that throughout that group. All these middle ones that are in the shortened area, this is called your transition metals. And the transition metals do not follow this rule. They are considered kind of like the unruly teenagers where they don't follow rules, in that they could change the amount of valence they have. So we're not going to talk about them as we're talking about this portion where we're going to talk about ions because they can vary. So we're going to go ahead and move over here to group 13, and group 13 is going to pick up with this pattern, and it's going to have 3, that was really bad, 3 valence electrons. Group 14 is going to have 4 valence electrons. Group 15 is going to have 5 valence electrons. Group 16 is going to have 6. Group 17 is going to have 7. And group 18 is going to be full. And I don't want to say that it's going to have 8 because helium doesn't. Helium only has 2 electrons, but the first orbital can only hold 2, therefore it is full. But the rest of them are going to have 8 in their outermost shell. What's important about that, knowing that they're full, is that they're not looking to give or take electrons. They're already stable and happy all by themselves. So these elements are usually found by themselves in nature, not bonded to other elements making compounds. So now that we've talked about the valence, I'm going to go over and I'm going to explain to you real quick what's going to happen and how this element's going to become charged. So right here, I've diagrammed the electrons of magnesium. So magnesium has 12 electrons, with the first orbital holding 2, the second orbital holding 8, and the outer orbital holding 2. So this outermost orbital only has 2 electrons on it. That's its valence number, and it was in group 2 of the periodic table. It would need 6 in order to fill its outermost orbital, and that's not going to happen. There's not going to be something that's just going to give it 6 electrons. So an element that only has 2 in its outermost orbital, it's more likely to give electrons away. So if it gives 2 of its electrons away, what's going to happen to it? So it had 12 electrons, but if it takes and it just gets rid of these 2, then you're going to have to minus 2 electrons. Well, if you end up subtracting electrons, okay, let me make this a little bit smaller. If we end up subtracting electrons, our protons are going to stay the same. The protons can't change because the proton is the identifying thing of an atom. The fact that it has an atomic number of 12 is not going to change, because if it was anything other than 12, it couldn't be magnesium anymore. So what can happen to it, though, is its electrons can change. So the protons are going to stay the same. It's going to have 12 protons no matter what. So I'm going to put 12p here. But if it gives these 2 electrons away, then now it's only going to have 10 electrons. Well, our protons are the positively charged particle, and the electrons are the negatively charged particle. So now we have more protons than we do electrons. And so if you can see here, now we're going to have a positive 2 charge because there's 2 more positive particles than there are negative particles. So it's going to have a positive 2 charge. So it has become an ion that has a positive 2 charge. So now I'm going to go back to this and I'm going to explain to you right here. Let me grab a different color. And what we need to know here is to understand now that if we know this only has 1 valence electron, it's more likely going to give that electron away, because if it's one of these elements that needs 7 to be full, well, something's not going to give it 7 electrons. So it's going to give that outermost electron away. And by giving an electron away, it now has more protons than it does electrons. So group 1 is going to carry a +1 charge because they're going to have 1 more proton than they do electron. Group 2 is going to have 2 electrons in its outermost shell that it's going to give away. Well, if it gives 2 electrons away, now it has 2 more protons than electrons. So it's going to have a +2 charge. Going to group 3, here we still need 5 electrons to be full. We're not going to get that. So we're going to say that this is going to be a +3 charge. But now when you get to group 4, this is right in the middle. So it could give or take. So this one could really be either. I'm not going to identify it as a plus or a minus because it could go either way really with that. But once we get to group 5, at this point in time, we only need 3 electrons to be full. So it's more likely that it's going to take or share, gain 3 electrons. So now at this point in time, we have more negatives than we do positives. So if it gains 3 electrons, it's going to become a -3 charge. Well, when we get to this group that they have 6 valence electrons, they only need 2 to get full. So they're more likely to take 2 electrons, giving them a -2 charge. This group right here is more likely to gain 1 electron so that it can be full because it currently has 7. So it's going to have a -1 charge. This group right here it's stable. It's going to stay stable. So this is an explanation of what's going to happen with ions. It is a charged particle where electrons are either given, taken, or shared, and the atom now became charged due to the fact that it gained or lost electrons. The other thing that you have in your thing is it talks about isotopes. And I'm just going to drop a text box in here real quick and explain something to you real quick about isotopes. So what an isotope is it is just where the element is going to have different masses. Okay? So a good example of that is like carbon. On the periodic table, carbon is carbon 12 because it has a mass of 12. But there is also a carbon 13, a carbon 14, and that just says different things about their mass. Well, at carbon 12, at that time, it has the only thing that we're going to talk about with an isotope is its neutron count changing. So at 12, its neutrons was equal to 6 because 12 minus 6 is 6. This atomic number can't change or it wouldn't be carbon. If it was 5, it'd be boron. If it was 7, it'd be nitrogen. So now at carbon 13, if it had a mass of 13, I would say 13 minus 6. Well, now it has 7 neutrons. So its neutron count changed. So here, the next thing would be is if it was carbon 14, well, its neutron count is going to be 14 minus 6. It's now going to have 8 neutrons. So the neutron count is just what's changing for an isotope. Something that some of you might be familiar with, especially if you had a high interest in like fossils and things like that, you might be familiar with the isotope carbon 14 because that's what's used in carbon dating to determine how old a fossil or something that was previous living would be. They would be able to determine how much of that isotope was still remaining in whatever that living being was, and that's how they would help like date it to determine how long ago it was actually alive. So an isotope is just a variation, a change in the number of neutrons that an atom can have. So the only two particles that can actually change for an element is going to be its electrons and its neutrons. If its electrons change, then that is where it's become an ion. If its neutrons change, that is an isotope. So one other thing that I wanted to show you guys real quick is I wanted to show you how to open these CAMI assignments so that we don't have any issues with this. So when you go to it and you click on it and you go PDF, you're always going to go open with, annotate with CAMI. And it's going to be like that for all of these assignments. Every one of them I have assigned via CAMI. They're PDF via CAMI. So click that, go open with CAMI. This one down here, click this, go to PDF, open with CAMI. Okay? So that is how to do all of these assignments. That's an explanation of the ions and isotopes. I hope this helps you. If you have further questions, you can email me or I can set up a Google Meet with you. Have a great day.